So the synthetic routes which we use to prepare different substances, we can have different synthetic routes. Let's say we want to produce like aromatic compounds, different aromatic compounds are there. So for aromatic compounds, what we can do, we start with a main aromatic compound, which is a benzene. So make it as a central compound. So we have a benzene, which is the main central compound. Now from this benzene, we can produce different substances, different aromatic compounds. If we want to produce a bromobenzene means like a bromine substitution we want. So if I want to produce a bromobenzene, a bromine is attached. It can be multiple as well. Multiple substitution can happen or occur. But if I want a single substitution, so what I need a bromine and I need a halogen carrier, which is acting like a catalyst. So AlBr3, which will be a catalyst for this reaction. If I want to produce a methyl benzene, like this is a bromobenzene, but if I want to produce a methyl benzene means I need a methyl group in as the substituent. So what I should use the reaction conditions which I need. Again, I need the halogen carrier that is the catalyst for this reaction, and I should heat with a halogen alkane. Like if I need a methyl group, so I should heat with a methyl chloride. If I want ethyl substituent, I should heat with the ethyl chloride like C2H5. And if we want a benzoyl chloride means like benzene ring is there, and we have the C double bonded with O and Cl is there, the ethynyl chloride. So that is a benzoyl chloride. So if I need a benzoyl chloride, again I need AlCl3, the halogen carrier, and I because this is the thing what we need. It's easy to remember, like that should be there with a carbon chain. So CH3COCl will be there. So this will be substituted. As you can see here, CH3Cl, so Cl was substituted. That will produce a benzoyl chloride. If you want to do nitration of a benzene, nitration of a benzene means like if we want a nitrogen as a substitute, an NO2 as a substituent group, what we need a mixture of a sulfuric acid, which will be a catalyst around 50 degree, and we need a nitric acid. So a mixture of nitric acid and a concentrated sulfuric acid. But sulfuric acid is not a reagent here. It is a catalyst for this reaction, which produce an NO2 group that will be help in electrophilic substitution reaction. Around 50 degrees we want to maintain. Then if we want nitrate, like a nitrobenzene, if we want to convert into the phenylamine means a benzene ring with the amine group, we call that as a phenyl. Phenyl is a name given to a benzene ring. So this is phenylamine, means amine group, and the benzene ring is there. So what we need here, two things we have to do here. We have to reflux with tin and a concentrated hydrochloric acid, and then we have to add sodium hydroxide. So for a nitration, the first thing is a reflux. Reflux with what? Reflux with tin, a mixture of a tin and HCl. Because like we want to, this is a like a reduction. How it is a reduction? It's a removal of oxygen or addition of hydrogen. That's why we call it a reduction. So we need tin and hydrochloric acid, and then that is followed by addition of a sodium hydroxide. Then if a phenylamine we want to convert into diazonium compound, but the reaction condition is important. It should be less than 10 degrees, the temperature. And what is a diazonium compound or benzene diazonium chloride? In which nitrogen is there having four bonds. One with benzene and one with three bond with another nitrogen, and there's a plus charge. Look how nitrogen can form four bond. Nitrogen belongs to group 5. Group 5 can share three electrons. But this is a nitrogen atom. But if a nitrogen one electron is being lost, so it has four electron. So N plus, which is having four electron, it can form four bonds. But N, like a nitrogen without a charge, it can form three. But nitrogen with a charge can form four bond. That's why this nitrogen, which has lost its electron, is forming four bond. Three with nitrogen, one with the benzene. And then the negative charge chlorine is there, which is taking the electron of a nitrogen, is attracted. So this compound is known as diazonium chloride. And for it should be less than 10 degrees, like cold condition. And we need nitrous acid, HNO2. We need sodium nitrate and a hydrochloric acid. This is sodium nitrate. If the temperature is higher, then like greater than 10 degrees, then this diazonium compound will not form. As a result, what will happen? It will decompose and it will produce phenol, and the nitrogen gas and a water molecule is there. Yes, I'll repeat. Look, when we have a nitrogen atom is having three, like it has five electrons, so it has a tendency to form three bonds. But when a nitrogen lost one electron, if it is a charged, then now it has four electrons, so it can form four bonds. This is what happened. Here you can see two nitrogen are there. One is forming three bond, one is forming four bond. The one which is forming three bond is this one. This is forming three bonds. This chlorine is actually attracted towards this side. So this one of the nitrogen is forming three bond, which is a neutral. Another nitrogen, which is a positive charge, it is forming four bond, one with the nitrogen and remaining three, three with the nitrogen and remaining one with the benzene ring. And the chlorine, the chloride ion is attracted here, unlike charges attract. So there will be attraction. So instead of writing it here, we normally write the Cl here. But actually it is attracted towards the positive side, which is a diazonium azodie. So most of the colors, the dyes which are used for the for like the paints, the colors which we use for the clothes, different colors are there. So they are originated from this diazonium chloride or benzene diazonium. But if a temperature is high, if a temperature is more than 10 degrees, so this diazonium compound will decompose. It will produce phenol. Phenol means the OH group is attached, and it will produce nitrogen and it will produce H2O. So these are the products which are formed. So origin, like starting is a benzene. Like I will show the complete diagram, the synthetic route. This is like more detail. The one I gave is like a short introduction to the compound. As you can see, this is more detail and more changes are shown as well. We start with the benzene. So when we start with the benzene, if I react with a hydrogen, like and the nickel as a catalyst, it will produce a cyclic alkane. If I react with bromine and FeBr3 or AlBr3, I can use both of them. Like as a catalyst, I can use FeBr3 or I can also use AlBr3. So this will result in a formation of a bromobenzene. If I react with a chloroalkane and AlCl3 I use as a catalyst, so I can simply No, we don't use separately. It's a mixture of a nitrous acid and HCl. So not it's not one, they are both used together. So if you use a chloroalkane, like if I want a carbon chain to be attached, so what I need, like if I need a methyl, so I need a methyl chloride. If I need a ethyl group attached, so I need a ethyl chloride and the catalyst AlCl3. So this carbon chain will be attached with the benzene ring. I can use a fuming sulfuric acid. So this will be the product like sulfur trioxide. If I use concentrated nitric acid and sulfuric acid, so it will produce a nitrobenzene. Nitrobenzene, we react, mix with tin and HCl, it will reduce. And then sodium hydroxide is also added, NaOH is added at the last. So it will produce a phenylamine. This is a phenylamine. Phenylamine, I can react with a halogenoalkane. So substitution reaction to the hydrogen will be substituted. Or if a phenylamine is there, I use sodium nitrate and a hydrochloric acid less than 10. Nitrous acid is not a stable like sodium nitrate. This is the main reason for using a sodium nitrite, not nitrate. Nitrate is NO3, nitrite is NO2. So sodium nitrate and HCl, it will first produce a nitrous acid. Nitrous acid with the HCl together combine with this phenylamine to produce a disonium chloride. Like there will be Cl as well. We normally write Cl here, but actually it means like the Cl is attracted toward this. If we react with another like a benzene ring, then this reaction is called coupling. Coupling means when two benzene rings are linked with each other, we call them as a coupling reaction. So this is what the dyes, that's how the dyes are made up of. So we have a disonium chloride and then this disonium chloride, how a coupling reaction take place, I will draw that. Look, this is a disonium chloride. Now in a coupling, what will happen? We react with another benzene. And it can be any substituent benzene, like let's say we react with phenol. So we reacted with a phenol. Now what will happen? This Cl will be removed from here. And when this Cl is removed from here, this nitrogen, like this nitrogen, will take the electron back. So what we are left, so this Cl is removed from here and this H is removed from here, one of the H. And the two benzene rings are linked with the nitrogen bonds. Like this is the first benzene ring. This nitrogen now, it is neutral, so it can form three bonds. So this one of the bond will be broken. This nitrogen also, so it was already neutral. And this will form with the benzene ring. So this is called a coupling reaction when we link the two benzene rings while the nitrogen. So this coupling reaction, and this is actually a color. Like it's a color which is used for the clothes. Different colors are there, different because of the presence of the delocalized electrons. These compounds are highly colored, like blue, dark blue, green, light green. Any color is there depending on which two are coupled here. And it's not only for two, it can be multiple coupling, which result in a formation of a mixture of the colors. Is it clear? Any doubt in this? So this path is very important to understand. And we can also, if react with the acyl chloride, it will produce an amide, like amide linkage. This is amine and this is amide. If we have a acyl chloride in the presence of anhydrous aluminum chloride, so this will have a substitution C double bonded with O and CH3. So it means that will become phenyl ethanol. Phenyl is because of benzene ring is there, and eth because of a two carbon it is eth, and on is because of the presence of a ketone. So it is phenyl ethanol. What happened to the Cl? The Cl combined with the hydrogen, because in a coupling, one hydrogen will be removed and the Cl is removed, so they combine with each other. So it will produce HCl. Misty fumes will be there. Then this is a ketone group. If I react with NaCN and sulfuric acid, so nucleophilic addition reaction will take place. And if you remember that we did, like if we were having C double bonded with O and there was CH3 and CH3, and if we react with KCN and HCN mixture, so the hydrogen will be combined here and CN will be attached here. So this will become CH3, COH, CN will be there and CH3. So this is a hydroxynitrile group it will turn out to be. This is a hydroxy and CN is there, so nitrile. And if you react with HCl, the nitrile group will turn into a carboxylic acid. So the side chain, like this is a reaction with the side chain. A nitrile group can be heated. Nitrile group can be converted into carboxylic acid by simply heating with HCl. And if this is a ketone group is there, so we can do a reduction of a ketone will produce alcohol, and alcohol is there. If this alcohol can reacted with any like carboxylic acid or ethynyl chloride to produce what? It can produce an ester group. Like this OH can be turned into an ester group. So it's the same, like if it a reaction with the side chain, we follow this procedure. Because this is a reaction with on the side chain. These all are reaction on the side chain, like ketone turn into alcohol, alcohol turn into ester, ketone turn into nitrile, nitrile turn into carbo. So this is all side chain, which we have already discussed in the previous slide on this slide we have already discussed that how it can be done a nitrile to a carboxylic acid or to alcohol. So the top part of this chart is actually the substitution to the benzene group. Like all are substitution to the benzene group. And the bottom part, this part is actually the substitution to the side chains. Is it clear? Any question or a doubt?